This screencast briefly covers the Kuiper Belt and the Oort Cloud. These are the two regions in the outermost portions of the solar system that are basically fields, if you will, of debris that is left over from the formation of the solar system. The first is called the Kuiper Belt, and as is depicted on this slide, it is a disk shape of material that extends out past the orbit of Neptune to a distance of about 50 AU or so from the Sun. The Kuiper Belt is quite extensive. It's been estimated that there are at least 35,000 objects greater than 100 kilometers in diameter that makes up the Kuiper Belt. Pluto, for example, is one of the larger Kuiper Belt objects. A Kuiper Belt object, by the way, is abbreviated as a KBO. We've been aware of the Kuiper Belt for quite some time, a number of decades, and the reason for that is because it is the source of what are called the short period comets. These are comets that typically have orbital periods on the order of several decades or so, and all of the elliptical orbits associated with such comets are lined up with the ecliptic, the plane of the solar system. So then therefore, for that reason, we know that the Kuiper Belt basically lies along the ecliptic as well, that is within the plane of the solar system. The Kuiper Belt has been explored already to some extent, most famously by NASA's New Horizons mission. The New Horizons mission was launched in early 2006, and it took about 9 years for the spacecraft to make its way all the way out to Pluto. It did a flyby of Pluto, and it then continues out into the Kuiper Belt from there. The probe did a flyby of Pluto in 2015. It basically was our first visit to Pluto, this portion of the outer solar system. Okay, here's a very nice picture from New Horizons of Pluto. This was taken probably just a few hours or so before the closest approach of the spacecraft to the dwarf planet. Pluto is now considered to be one of the largest Kuiper Belt objects. Its distance from the Sun is about 39.5 AU. It was discovered in 1930. It's 1,400 kilometers in diameter, which is roughly the same diameter as the state of Texas. Pluto has a couple of moons. One of the moons was photographed very well during the New Horizons mission. This is the moon Charon. Charon is about half the size of Pluto, so it's quite large compared to Pluto itself. Pluto has a few other much smaller moons that weren't photographed nearly as well by the New Horizons mission. Okay, the New Horizons mission continued after the flyby of Pluto. New Horizons basically is keeping on going, if you will, out into the Kuiper Belt. And soon after the Pluto flyby, they used some of the fuel that was left on the spacecraft to steer it past this object here, which is called Erikoff. Erikoff is a double-lobed object that's quite small. It's only a couple of miles on a side, and it basically consists of these two lobes, if you will, here or here, that have undergone some sort of a collision in the distant past, and they then have stuck together due to their mutual gravitation. There are a few other large Kuiper Belt objects that we are aware of, even though we haven't done any flyby missions of them as of yet. This particular object here is called Qawar. It was discovered in 2002, and it was the first large Kuiper Belt object found that is other than Pluto. There's actually an object out in the Kuiper Belt that is larger than Pluto called Eris. We think it's about 10% or so larger than Pluto, and as you can see, it's on this highly inclined elliptical orbit. No spacecrafts as of yet have visited Eris. Okay, now let's move out to the Oort Cloud. The Oort Cloud is basically a spherical debris of leftover remnants of the formation of the solar system that extends out to about a half a light year. And by the way, all of this material that I've been mentioning with respect to the Kuiper Belt and now the Oort Cloud is basically consists of rocks and ice. To give you an idea of the sense of scale associated with the Oort Cloud, right here, for example, is the Kuiper Belt with Pluto's orbit highlighted, and then basically take the Kuiper Belt from earlier in this screencast and fit it down into this space right here. And then in 3 dimensions, like so, in a spherical distribution, we then have the Oort Cloud. The Oort Cloud is the source of the long period comets, so we know it's there for that reason. Long period comets are comets that have orbital periods on the neighborhood of thousands, or in some cases, tens of thousands of years. And then all of those long period comets, they do not come from a preferential direction in the sky like the short period comets do, lining up with the disk of the Kuiper Belt. So this basically indicates to us that the Oort Cloud itself is spherically distributed when the comets that come in from it they do not come in from a preferential direction. Incidentally, by the way, it is gravitational interactions that occur between these objects that periodically sends one of these objects down into the inner solar system to become a comet. Okay, this first Oort cloud object that we have discovered is an object that is way out there in the solar system called Sedna. It was discovered about 20 years or so ago. To give you an idea of the sense of scale associated with Sedna's orbit and its location within the inner portion of the Oort cloud, we first of all have right here on this slide the inner portion of the solar system. We have the Sun, Mercury, Venus, the Earth, and so on. Take this box right here and then fit it into here like so. We can see the outer portion of the solar system extending out into the Kuiper Belt. And then take this slide here and extend it down into here. This is then roughly where the inner portion of the solar system is. And then this red ellipse that you can see right here, this right here is depicting the orbit of Sedna. So for example, right here, once again, is the outer portion of the solar system. It's basically this little box right here. So Sedna is way out there in the solar system. Okay, we have photographed Oort clouds forming around young stars elsewhere in the galaxy. That's what these little blobs that you can see right here are. These are actually forming Oort clouds, and these Oort clouds extend out to distances of roughly a half a light year or so from the stars that are forming within. This particular photograph was taken deep within a region of what is called the Orion Nebula, which is a major star formation region that is close by in the Milky Way. Here's another close-up of one of those objects. What you're seeing here is basically a photograph of a very young solar system, and the star itself is buried deep within this debris, and then planets and so forth are forming around it. Okay, so that concludes this short screencast introduction to the Kuiper Belt and the Oort Cloud.